Okay, now this video looks at how to find a domain and range of a function or a relation. Okay, now what exactly is domain? So here if you look at the formal definition of domain, we have seen that relation is a set of points which connects two variables. It connects x with y. The domain of a relation is a set of values which the variable on the horizontal axis take. The horizontal axis is the x-axis. So what is the minimum value this is taking? What is the maximum value this is taking? This is the domain. So if this is A, this is B, both these values are taken. So you can say that your A, B, this is the domain. You can also write A is less than equal to X is less than equal to B. You can write like that. This means that these values are included. This is included and this is also included. Both are included. So suppose that this y value is C and y value is D. So domain basically is the value X values that the function takes or the relation takes. Range is the y values. The range of a relation is a set of values which the variable on the vertical axis take. So there's a set of y values. So you look at the minimum, so your minimum and maximum. So similarly minimum y, maximum y. Minimum y is C, maximum y is D. So that's the range of this function. So you can also write like this. Fine, both means the same thing. These are all, both these are equivalent. So you can either write like this or like this. Let me show you with some examples over here. Examples, state the domain and range of the following. So in this case, they've given you the graph. So if they give you the graph, what you need to do is you look at the domain when you're writing, you look at the minimum x and the maximum x. So the minimum x value is your -1. And the maximum is going on the right because this graph is going like this only, it's going to the right. So it's going to the right. So -1 to infinity. Now remember, infinity will be excluded. You can write your domain like this. You can also write your domain x is greater than equal to -1. No problem. It means the same thing. Either write this or this. Range. When you're finding the range, what you need to do is minimum y value, maximum value. Lowest and highest. Domain is leftmost and rightmost. This is lowest and highest. So lowest value it takes is -3. -3 is the lowest value. And this graph keeps on going up. So this is going to infinity. Infinity is the highest value. Or if you want to write like this, y is greater than equal to -3. This is the range. Now whenever they give you a graph like this, to write a domain and range, you need to find out the local maximum or the local minimum. This is called a local maximum. So here they've given the graph. So you look at the minimum value. So leftmost value. Now look at this. This keeps on going left. This keeps on going right. So domain is from -infinity to +infinity, or you can write x belong to set of real numbers. That's your domain. It can take any value. Range is minimum y to maximum y. So the graph is not above this. So minimum is -infinity. Maximum value it takes is 1. Obviously this is x and y. There's an ordered pair, there's a y value. Or you can say that y is less than equal to 1. Sorry, this 1 is included. So if your 1 is included, I have to put a box bracket like this. Yeah, this means that 1 is included. This dotted line is the vertical asymptote. Means this graph will approach this value but will never take this value. This graph will approach 2 but will never take this value. This is the horizontal asymptote. So nomenclature, this is the vertical asymptote. You spell asymptote like this. So this is the vertical asymptote and this is the horizontal asymptote. So whenever you're writing the domain and range, the asymptotes are excluded. So when you're writing the domain, you have to think of the leftmost and the rightmost. So leftmost is -infinity, rightmost is +infinity. So you can say -infinity to +infinity, and x is not equal to 2. You exclude the vertical asymptote. It doesn't take this value. When x is 2, the function is not defined. Range, you can say minus infinity. Lowermost is this goes to minus infinity. Uppermost this goes to plus infinity, but 1 is excluded. X is not, y is not equal to. Range you have to always write y, not x. Y is not equal to 1. Yeah. There are a number of ways of writing it. If you want to write using this, you can say the other way of writing it. X belongs to set of real numbers. X is not equal to 2. Y belongs to set of real numbers. Y is not equal to 1. So that's how you write your domain and range. So domain are the x values, range are the y values. Lowest, highest, and excluded unit. The next concept you need to know is the implied domain of a function. Now what exactly means implied domain? Sometimes they give you a function, especially, and they'll ask you to write down the domain and range without a calculator. So if your function is of the form fx the whole square, then your implied domain is minus infinity to plus infinity. Example, if I give you x plus 1 the whole square, your implied domain will be this. Okay, so function and then the domain. So this is the implied domain. So if you have any function whole square, it's minus infinity to plus infinity. If you have square root of any function, its domain is you have to solve fx is greater than or equal to 0. So example, so suppose if they give you in non-GDC, okay, find the domain of this function, let's say 3x minus 1. I'm making a question. So this is the example given to you, okay, find the domain of this function. So what you do is, whatever inside the square root, you make that greater than or equal to 0 and solve it. So you solve greater than or equal to 0, therefore x is greater than or equal to 1/3. So your domain is, this is your domain. You can also write like 1/3 to infinity. You can write like this. If you have 1 upon fx, then its domain is your function is not equal to 0. Example 3. So suppose the question, they've given a question, find the domain of this function. 2x. I'm just giving you an example. So 1 over some reciprocal function. So your domain, so you must learn this table up for the implied domain. So what will happen? You will do 1 minus 2x is, the denominator can't be 0. Remember that. You can't divide by 0 basically. It can be any number also on top. Doesn't matter. It can be any number on top. Your domain will always be denominator not equal to 0. So 2x is not equal to 1. So x is not equal to half. So that's my vertical asymptote basically. So your x belongs to a set of real numbers. X is not equal to half. That's your domain. 1 upon square root of fx. Then your domain will be fx is greater than 0. So you just solve this greater than 0. So if I give you, let's say, root of, I'm giving you 2 minus 4x. Okay. So what you do is, whatever this function is, whatever is inside the square root, because it's a denominator, it's only greater than 0. So 2 is greater than 4x. 2 is greater 2 upon 4. So x is less than half. So my domain is x is less than half. So from minus infinity to half is excluded. Minus infinity is also excluded. So x is less than half. All the values on the left hand side of x will be the domain. The next type is, you can also look at the graph and write down the domain and range. And obviously you won't be able to sketch this without calculator. So they'll give you calculator, no matter what calculator you use. You should sketch the graph, find the maximum, minimum, and write the domain and range. So let me show you an example. I'll show you using Desmos over here. So what will I do is, so in exams I'll be using a graphic calculator. Here right now I'm using Desmos because I don't have this calculator program on this particular laptop. So I've used Desmos. I'm going to graph this. So graph that. Get the max. Get the min. Correct? Now look at the domain. Domain are all the x values. So imagine which are the x values it can take. This is, what is the leftmost this can take? This can go to minus infinity. This is going to plus infinity. So domain is, so if you sketch the graph, so if you are sketching the graph, your graph is something like this, now passing through the origin. This is your graph. So you look at the leftmost value and look at the rightmost value. This continues to infinity. So your domain is your x belong to set of real numbers. Any real number. Your input can be anything. Remember, your domain is your input, which can take any. You can take any value. Does no matter. It doesn't become undefined ever. There's no denominator to worry about. Range, you'll have to look at the max and min. Now in this case, the max and min get redundant because you have a y value which is overshooting the max, and you have a y value which is going below. So you look at the lowest y value, which can be anything, highest y value which can be anything. So y belong to set of real numbers. The next one. So I'll graph this. Okay, so I've graphed this over here on Desmos. Now again you see, your x value can be anything. Your input can be anything in this case. You can put any value of x. It won't matter. But your y value, this is the minimum. Y is not going below -8. Here this is also there, but the graph is going below this, so you don't have to worry about this. Here. So this is your minimum. Y is -8 and it goes to infinity. Your domain is a set of real numbers. So B, domain x belong to set of real numbers, and your range is, you can write y is greater than or equal to -8. If you see the graph, I'm looking at the graph, y is greater than -8. The next one. Now again I graphed root of x square plus 4 in this case. So again your domain can be any number, any real number. You can put in any, your input can be anything, but the output is not going below this. Correct? Means your y is greater than 2. So domain x belong to set of real numbers and your y is greater than or equal to 2. Next, x square minus 4. So I'll just change the sign. X square minus 4 you have over here. Now this is interesting. Your domain are all the x values, so it can take all these x values, up till here, till -2. Correct? And 2 to this. And your range is going above, everything above this. So if I take the screenshot of this and put it here, okay, so you can see over here. So this is your y. You don't have to learn this graph, please. You don't have to learn this graph. You have to. This will come with calculator. This is D I'm doing. So your domain are all the x values. So you can say from -infinity to -2 included. So -infinity to -2 union 2 to infinity. That's your domain. Yeah. Or if you don't like writing like this, then you can write x is less than or equal to -2 union x is greater than or equal to 2. You can write like this also. Both are equivalent, doesn't matter. Range are the y values. What is the minimum y value? This is your minimum y value. This is your 0. So range is y is greater than or equal to 0. That's your range. Or if you want to write in the bracket notation, so you have 0 which is included and infinity which is excluded. You can write like this or like this. Doesn't matter. So domain and range is always slightly tricky. So what you need to remember is looking at the graph, how to write the domain and range. Looking at implied domain, this is the second thing. Without calculator for HL, this is very important. And using your GDC to find the domain and range if it's a tough function. Correct? Without calculator, they'll ask you only functions of this sort. So you need not worry about other types.